Hi everyone, welcome back to Pullas Academy. This is physics class for research students by Kiran Kumar Adarapu. Today we are going to discuss about part 4 video in elements of vectors. Here we will discuss about the parallelogram law of vectors and its applications. Okay, no? So for addition of any two vectors, we need parallelogram law of vectors. That's why we will discuss clearly about the parallelogram law of vectors. Okay, no? How to addition any two vectors. Here by application of parallelogram law of vectors, it is very easily you getting. That's why we will discuss about the parallelogram law of vectors. Okay na? ఎప్పుడైనా ఏవైనా టూ వెక్టర్స్ని అడిషన్ చేయాలంటే ఖచ్చితంగా వీ హ్యావ్ టు అప్లై ద parallelogram law of vectors. ఓకేనా ఫస్ట్ ఐ వాంట్ ఎక్స్ప్లెయిన్ అబౌట్ ద స్టేట్మెంట్ ఆఫ్ parallelogram law of vectors. ఓకేనా let us discuss about the statement. What is the statement here? So according to the statement, if two vectors are acting at one point with some angle in a plane, these are represented as adjacent sides of parallelogram. So then at the same point, the diagonal of parallelogram is represented as the resultant of these two vectors, both in magnitude and direction. So that is the statement. That means if you consider two vectors, they are acting at one point with some angle in a plane or represents as adjacent sides of parallelogram. So at the same point where the two vectors are acting at the same point, imagine the diagonal of that same parallelogram. The diagonal represents the resultant of these two vectors. Okay, now what is the direction of the these two vectors? Along the diagonal, its resultant vector is acting. The length of the side length of the diagonal indicates the magnitude of these two resultant vector. This is about the statement. Now we are going to discuss here mainly the most important expression is the expression for magnitude of resultant vector and direction of the resultant vector. Now we are going to discuss about the magnitude and direction of the resultant vector. That's the topic. Okay, right. First I want to explain about the magnitude of the resultant vector. So here we will discuss about the magnitude of resultant vector. Magnitude of resultant vector denoted by capital R. Okay, right. So how can we derive the expression for magnitude of resultant vector? Listen to me. So here in this derivation, according to the statement, these two vectors acting at one point with some angle are represents as adjacent sides of parallelogram. That's why we have to imagine the parallelogram. Suppose I consider this is one point here. O is one point. Here acting two vectors. This is one vector suppose. If you consider one more vector, this is. Suppose I consider this is P bar vector. This is Q bar vector. These two vectors are acting at one point with some angle. Okay, now these two vectors are represents as adjacent sides of parallelogram. That's why we have to consider these two vectors are adjacent sides of parallelogram. So when you consider, if you complete the parallelogram, then understand what is the diagonal of this parallelogram. Okay, now how to complete the parallelogram? Draw the equivalent parallel side to P bar vector and draw the equivalent parallel to this vector. Then you get a parallelogram. That means its equal side, equivalent parallel side, its equivalent parallel side. If you complete, so then you get a parallelogram. In this parallelogram, this is the one point. Suppose if you consider along OA side acting P bar vector, along OB side Q bar vector is acting. So when you extend, when you draw the parallel and equal side, then they are intersect at one point. That point is another corner of the parallelogram. If you connect these 2 points O and C at the same point, you want a diagonal. It is also one of the diagonal, but where these two vectors are acting at the point, imagine the diagonal. Along this diagonal, its resultant vector is out. This is the R bar vector. What is R bar vector? Along OA, OC side acting R bar vector. So this is about the parallelogram. Okay, so in this way we have to understand two vectors acting at one point with some angle or are represents as the adjacent sides of parallelogram. At the same point, the diagonal of parallelogram indicates the resultant of these two vectors. Both the magnitude is indicated by this diagonal, and not only magnitude, the direction is also indicated by this diagonal along this OC side acting its direction, resultant vector direction. This is the statement and it is the explanation. Now we will discuss an expression for magnitude. How to, suppose if you want to derive the expression in this way, it is possible. Suppose this OA side is extend to the OA side here. This is the extension. Okay. Next, draw the normal line from C. Suppose this is imagination. That's why I indicated by distance. This is what discontinuous lines. Where they are intersect here, this is point I consider D. Now you get, when you extend and draw the normal line, if you observe in the diagram, so OCD is one right angled triangle here. In this triangle, one of this is 90 degrees right angle, its opposite side OC is the hypotenuse. Okay, in this triangle OC is the hypotenuse. This hypotenuse is indicates the magnitude of the resultant vector. That's why based in this triangle, if you define the Pythagoras law, you get the expression for magnitude of the resultant vector. That's why I want to extend this OA side and draw the normal line. Then you get a right angle triangle. In this right angle triangle, we have to derive the expression for magnitude of the resultant vector. That is the procedure. Okay, so now I want to explain that. In triangle, when you extend like this, in triangle OCD, if you define Pythagoras law, based on the Pythagoras law, here OC square is equal OD square plus CD square. What is the formula here? OC square is equal OD square plus CD square. This is the formula. Okay, now this is called hypotenuse square is equal to base square plus height square. Okay, now? So listen to me, all of you. OC stands for along OC side which is acting R bar vector. Its magnitude is simply is denoted by what? Modulus R bar. Modulus R bar is simply is denoted by R. That means OC, this length of this line segment is R. Okay, now that's why instead of R, right, OC stands R square. OD stands for, from the diagram, this is OD. So OD is similar to, it consisting of OA plus AD. That means OD, instead of OD, write OA plus AD plus CD. OA plus AD whole square plus CD square. This is called as R square. OA plus AD whole square plus CD square. Again simplify this, A plus B whole square. According to A plus B whole square formula, OA square plus AD square plus 2OA into AD. Okay, now plus we have CD square. This is the formula. After simplification, you get this. Here OA stands from the diagram along OA side P bar vector is acting. This length of this line segment is similar to the magnitude of the P bar vector, that is modulus P bar, or that is similar to P. That means instead of OA, write P square plus AD. We don't know AD, write as it is. Next, plus 2 into OA stands P into AD. What is CD? We don't know CD also, write as it is. This is the expression for R. We need R. But here AD, CD is unknown values. First find out AD, CD in terms of P, Q and theta. What are the known values here? Here two vectors we have at a point with some angle. That means the angle between two vectors is a known value. And what is the vectors? What is the magnitude and directions of these two vectors? It's a known value. That means this AD is unknown value, CD is unknown value. These two values are right in terms of known values. After that, substitute in the formula, you get the magnitude. What is the procedure here? Listen to me. So in this triangle, if you consider this is extend line, this is parallel line, that's why here also same angle. It makes same angle. That means here we have one more triangle, in triangle ACD. So if you need AD how to getting, this is theta, its opposite side is CD. So adjacent side is AD. Suppose if you consider sin theta definition, that is opposite side by hypotenuse. What is opposite side here? Opposite side is CD, hypotenuse is what here? This is theta, its opposite side is AC. AC stands for OB AC is parallel and equal sides, that's why it is similar to Q bar. Its magnitude, AC, the side length is similar to modulus of Q bar, that is similar to Q. That means here we have to consider this AC stands Q. AC stands what? Q. OP, then you have to write CD by AC stands Q. This is sin theta is equal CD by Q. Then here in the expression CD is equal Q sin theta. What is CD? Is equal Q sin theta. In the same way, if you want to discuss cos theta, define cos theta. Cos theta is equal, what is the formula here? Adjacent side by hypotenuse. Adjacent side is what here? AD is the adjacent side, AC is the hypotenuse. Then cos theta stands AD. AD stands what here? This is, we don't know, AD. AC stands Q. Again, if you write as a subject AD, that is similar to Q cos theta. What is the formula for AD? So this is a formula just from the derivation understood. CD stands Q sin theta, AD stands Q cos. Q cos theta is a known value, Q sin theta is a, theta is a known value, Q is a known value. That's why now substitute in the formula, you get everything. P, Q, theta are the known values, substitute, you get it. So this is the expression for resultant vector magnitude in terms of known quantities. This is a procedure. Now I want to substitute these two equations in this equation. Now these CD and AD values substitute in this equation, you get here R square is equal, already we have P square plus AD square. AD means Q. Q cos theta whole square means Q square cos square theta. Next plus 2P into AD. AD stands what here? AD stands Q cos theta. Next plus CD square. CD again Q sin theta whole square means Q square sin square theta. So after simplification you get P square plus here, listen to me, Q cos square theta, Q square cos square theta, Q square sin square theta. Q square is take common. What is the expression here? Sin square theta plus cos square theta. So this is the formula plus 2PQ cos theta. Okay, now in this way we have to consider this expression. So now here simplify in this way, P square plus Q square into sin square theta plus cos square theta is 1 plus write 2PQ cos theta. Okay, now it is similar to P square plus Q square plus Q square into 1 Q square plus 2PQ cos theta. This is similar to R square. Actually it stands for R square, but we need R equation. Write as a subject R. What is the formula here? Under root of P square plus Q square plus 2PQ cos theta. This is the most important expression. Must and should concentrate and try. Okay, na? So it's the most important equation in this topic, in this elements of vector. Must and should concentrate here. If you want addition any to vector, must and should follow based on the parallelogram law of vectors. It is only possible. So we have to use this formula. R is equal to under root of P square plus Q square plus 2PQ cos theta. P is the magnitude of the first vector, Q is the magnitude of the second vector, theta stands the angle between P and Q. So this is about the derivation of the magnitude of the resultant vector. Okay na? Ikkada ఈ పైథాగరస్ లాలో మనం అకార్డింగ్ టు పైథాగరస్ లా హైపోటెనస్ స్క్వేర్ ఇస్ ఈక్వల్ బేస్ స్క్వేర్ ప్లస్ హైట్ స్క్వేర్ ఈక్వేషన్ ప్రకారం రాసు. ఇక్కడ OC అనేది రిజల్టెంట్ వెక్టర్ మ్యాగ్నిట్యూడ్ ఈక్వల్ కనుక ఇక్కడ ఆర్ రాసుకున్నాం OC బదులు. OA అంటేనేమో OD అంటే ఏంది? OA ప్లస్ AD కనుక OA ప్లస్ AD హోల్ స్క్వేర్ రాసి CD స్క్వేర్ రాసి దీన్ని సింప్లిఫై చేస్తే A ప్లస్ B హోల్ స్క్వేర్ ఫార్ములా ప్రకారం సింప్లిఫై రాసి OA is equal P సబ్స్టిట్యూట్ చేయండి. నెక్స్ట్ రిమైనింగ్ యాజ్ ఇట్ ఈస్ గా రాసి AD CD అనేటువంటి దీస్ ఆర్ అన్నోన్ క్వాంటిటీస్. దట్స్ వై సో బేస్డ్ ఆన్ ఇన్ దిస్ ట్రయాంగిల్ యాక్చువల్లీ known values are theta and Q. So by using these known values, write AD and CD, define sin theta cos theta like this and you get AD CD values. ఈ రెండు వాల్యూస్ ఇదే ఈక్వేషన్ లో సబ్స్టిట్యూట్ చేసి సింప్లిఫై చేస్తే ఫైనల్ గా మనకి ఏమొచ్చింది? అండర్ రూట్ ఆఫ్ P స్క్వేర్ ప్లస్ Q స్క్వేర్ ప్లస్ 2PQ cos. జస్ట్ మనకు టూ వెక్టర్స్ మ్యాగ్నిట్యూడ్స్ ఆర్ వెక్టర్స్ మధ్య ఉన్న యాంగిల్ తెలిసేయచ్చు. ఆ రెండు వెక్టర్స్ యొక్క resultant vector addition of that two vectors is possible to measure by using this equation. This is the procedure. Now we are going to discuss about the direction of resultant vector. So actually in this is resultant vector. It makes some angle alpha with the x-axis. So this is a this angle indicates the direction of the resultant vector, because OA direction is a known direction, but here OC direction is unknown. So that's why we have to compare with respect to the P bar vector direction, then understand what is the direction of the R bar vector. Why? Because P bar vector is horizontal direction. That means what is making angle by this vector with P bar vector indicates the direction of the resultant vector. That's the procedure. That's why I want to measure. So if you want to the direction of the resultant vector, again in the same, it is also in the right angle triangle. In triangle OCD, define tan theta. That means not theta. Here in this triangle, known angle is alpha. Here theta stands angle between P bar and Q bar vectors. Don't confuse. Alpha stands. This is the direction of the resultant. Okay, now that means the resultant vector making angle with P bar vector is called as alpha. That means here if you define in this triangle tan alpha is equal to opposite side by adjacent side. What is the formula? Opposite side by adjacent side. What is opposite side here? CD is the opposite side. Adjacent side is what? OD is the adjacent side. Okay. Next, now tan alpha is equal CD by OD. OD stands what here? OA plus AD. From the diagram understood, OD stands OA plus AD. Now known values here. CD stands what? Already we have constructed. CD indicates what? CD indicates Q sin theta, whereas OA indicates P plus AD indicates Q cos theta. Already we have derivated these out. This is about the tan alpha equation. Tan alpha is equal Q sin theta by P plus Q cos theta, or it is also similar to alpha is equal tan inverse of Q sin theta by what is formula? P plus Q cos theta. This formula indicates the expression for direction of the resultant vector, or tan alpha is equal Q sin theta by P plus Q cos theta. If you know just P and Q values and theta, understood the direction of the resultant vector also. This is the procedure. Okay, is it clear? I hope you understood. So here just important is these two expressions. Here not asking the derivation. For your understanding I explain, but here mainly what is the magnitude of the resultant vector? So that is under root of P square plus Q square plus 2PQ cos theta. What is the formula for direction of the resultant vector? Based on parallelogram law, tan alpha is equal Q sin theta by P plus Q cos theta. These two expressions are important. You have to focus on these two expressions. Now we are going to discuss some special cases on parallelogram law of vectors. The first case is case 1 here. This is case 1. Right. Case 1 is if the angle between two vectors is 0 degree. That means given two parallel vectors. If theta is equal 0 degree, then what is R? What is the magnitude of the resultant vector? This is the question. Okay, now? So that means theta is equal 0 degree means this is P bar vector, suppose this is Q bar vector. These two are the parallel vectors. If the directions of two vectors is same, that is parallel vector. If you given two parallel vector, what is the magnitude of the resultant vector? How can we find out here? So general expression R is equal based on the parallelogram law of vectors under root of P square plus Q square plus 2PQ cos theta. This is the formula. Okay. Here where theta is equal substitute 0, then you get the resultant vector, that is P square plus Q square plus 2PQ into, instead of theta substitute 0 degree, then cos 0 degree. It is similar to P square plus Q square plus 2PQ into cos 0 degree is 1. 1 into 2PQ is 2PQ. That means this is similar to P plus Q whole square. Under root here, square root cancel, then you get P plus Q. So this is a very important point here, asking questions like this. So if the angle between two vectors is 0 degree, then what is the resultant vector? P plus Q. Okay, now P and Q bar vectors is given. The magnitude of the resultant vector R is equal to P plus Q. Then what is angle between two vectors? 0 degree. If the angle between two vectors is 0 degree, then resultant magnitude of resultant vector is P plus Q, based on this form. Okay, right. Next, second one is So second case is case 2a. Here suppose angle is, if the angle between two vectors is 90 degree, if theta is equal 90 degree, then r is equal what? Same formula. 90 degrees means suppose this is p bar vector, so this is q bar vector. So next, what is angle here? 90 degrees. So then if you substitute in the same formula, r is equal to under root of p square plus q square plus 2pq into cos 90 degrees. Theta is equal, substitute 90. So if you simplify, under root of p square plus q square plus 2pq into cos 90 degrees stands 0. 0 into something 0. That means final expression is p square plus q square. So this is about the resultant vector. Okay. So when if you have to write perpendicular vectors, what is the magnitude of the resultant vector? Under root of p square plus q square. It's the very important. Already I explained in the basics. One vector you have, that is r bar vector in xy plane. That r bar vector is equal to x I cap plus y j cap. This is the vector, but magnitude equation I given directly under root of x square plus y square. Why here given under root of x square plus y square? This is x component, y components are perpendicular to each other. If they are perpendicular to each other, so formula is under root of p square plus q square. Instead of p and q, we have x and y. That's why here under root of x square plus y square is the formula. That's the application. This is also application of parallelogram law of vectors. Okay, so we will discuss one more application, that is case 3. Case 3 is if theta is equal to 180 degrees suppose. So then what is r? What is r? R is equal to under root of p square plus q square plus 2pq into cos 180 degree. Okay, now what is the formula? Cos 180 degree. Cos 180 degrees stands what? Under root of p square plus q square plus 2pq into cos 180 is minus 1. So after simplification, under root of p square plus q square plus into minus 2pq. This is a formula, that means here p minus q whole square under root. Square root cancel, finally p minus q is the resultant vector. Okay, now what is the formula here? R is equal p minus q. So these are the different special cases of parallelogram law of vectors. Here one more point here, actually if theta is 0 degree and these two vectors are equal vectors, suppose p and q equal vectors means p is equal q and theta is 0 degree, then what is r? R is equal, substitute in the formula p plus p. Suppose q is equal to also substitute p, then you get 2p, or otherwise p is equal q substitute, then you get 2q. If the two equal vectors with 0 degree, this is a resultant. If two equal vectors with 90 degree, then what is resultant vector? Here actual formula, in this formula substitute under root of p square plus q is equal to also substitute p. So then under root of p square plus p square, that is similar to 2p square. 2p square means what? Root square cancel, then you get root 2p. What is r is equal to root 2p or root 2q? Instead of p is equal to also q, that's why write in terms of q also. So here what is the formula? P is equal q, substitute in this, theta is equal 180, p minus p is 0, then r is equal 0. If you have two equal vectors with 180 degree, resultant vector 0. Okay, if you have two equal vectors with 90 degree, resultant vector is root 2p. If you have two equal vectors with 0 degree, then 2p. Okay, one more important case here. If you have two equal vectors, suppose p is equal to q. Okay, so then and angle is theta is equal 120 degree. What is resultant? So here resultant vector r is equal to under root of p square plus q square, means instead of q write here p square because these two are same. Then p into q, q stands again p into cos 120 degree suppose. If you simplify this, under root of 2p square plus 2p square into cos 120 stands minus 1 by 2. So these two cancel, under root of 2p square plus into minus p square, that means 2p square minus p square is p square, root p square, square root cancel p, that means r is equal p, r that is equal q. That means if you have two equal vectors with 120 degree, resultant vector also similar to the these two vectors. It is similar to P vector, P bar vector magnitude and Q bar vector magnitude. So this is one more case here. If you have two equal vectors with 120 degrees, resultant vector also similar to the given vector. So these all are the special cases. Students should focus on these all special cases. 90% on parallelogram law of vectors. Here question asking. Sometimes giving this expression and asking what is angle. Sometimes angle is giving, asking this expression. Okay, sometimes the values P and Q values is given, asking or if the angle is 0 degree, if the angle is 90 degree, 180 degree, 120 degree. Okay, na? So most important formula, this is the important formula. Now we are going to discuss some previous and model ESET exam questions. Okay, so here the first question is, it is repeated in ESET 2020 TS paper. The question is, if modulus of A bar plus B bar is equal modulus of A bar minus B bar, then the angle between the two vectors is asked. Modulus of A bar plus B bar means actually, according to the parallelogram law of vectors, R bar is equal P bar plus Q bar. This resultant vector is equal. So if you want modulus of R bar, what is the formula? Under root of P square plus Q square plus 2PQ cos theta. This is a formula based on the parallelogram law. Instead of P and Q, given A and B. Modulus of A bar plus B bar means what? Here asking modulus of R bar indirectly. Okay, now that means under root of, here from the given value, actual given is modulus A bar plus B bar is equal modulus A bar minus B bar. So based on this formula, under root of A square plus B square plus 2AB cos theta, after this magnitude is according to the formula. It is similar to here, its resultant is also similar, A square plus B square. So minus stands what? Here the angle between is 180 degrees, that 180 minus theta, that's why you get minus 2AB cos theta. Just you get here negative sign for A bar minus B bar. Okay, now that's the difference. If you want to simplify this equation, squaring on both sides, then you get A square plus B square plus 2AB cos theta. It is similar to A square plus B square. Next what? Here minus 2AB cos theta. This is the formula. Again simplify this. This A square, B square cancel. This is 2AB cos theta. Minus 2AB cos theta is shifting into left side. Already 2AB cos theta. 2AB cos theta plus 2AB cos theta is 4AB cos theta. So is equal to 0. Okay, so this product is 0 means what? When it is possible, if anything is 0 in the product, that will become 0. That means 4 is not equal 0. A is the magnitude of the vector, it is not null vector. That's why A is not possible to 0. 4 is not possible to 0. B is not possible to 0. That's why which is only possible? Cos theta value. Because cos theta value changes from minus 1 to plus 1. That's why cos theta is equal 0 stands, but when cos theta value is 0, cos 90 degrees stands. Cos 90 degrees 0. That means theta is equal what? Cos theta is equal cos 90 degrees means theta is equal 90 degrees. That's which is correct here. Third option is correct. Most important question here. Next similar question here. So modulus A bar plus modulus B bar is equal modulus C bar and A bar plus B bar is equal C bar. Then what is angle between A bar and B bar? That means R bar is equal P bar plus Q bar. Then modulus R bar is equal this. That means here in the question, in this way you have to understand R bar is equal P bar plus Q bar is given. So and from this formula, modulus R bar means R is equal, what is given? P plus Q is given. So modulus A bar stands P, modulus B bar means P. So when it is possible here, R bar is equal P bar plus Q bar. So then R is equal P plus Q. Then what is angle here? 0 degree. If angle between two vectors is 0 degree, then that is possible. In this equation, if you want to conclusion, that is actual formula is under root of R square. R square means P square plus Q square plus 2PQ cos theta. Cos, if you consider 0 degree, cos 0 degree, that means under root of P square plus Q square plus cos 0 is 1, that means 2PQ. This is the formula. Then under root of P plus Q whole square, this is the formula. Square root cancel, what is the remaining? R is equal P plus Q. That means when R is equal P plus Q, if theta is equal 0 degree. That's which is correct here. Third option is correct. Next one is here modulus A bar square modulus B bar square is equal modulus C bar. then and a bar plus b bar is equal c bar, then what is angle? Same question here also. That means r bar is equal p bar plus q bar. In this way, very easily understood. Then what is given? This is p square plus q square is equal r square. When r square is equal p square plus q square means r is equal under root of p square plus q square. When it is possible, here theta is equal 90 degrees. It is possible in this equation theta is equal 90 degrees. It becomes 0. R is equal to under root of p square plus q square stands. R square is equal to p square plus q square. That's so which is correct here? 90 degrees. That's a simple solution. One more question here. Two vectors of same magnitude have a resultant equal to either, then the angle between two vectors. So already I explained p is equal to q. So p is equal to q and angle theta is equal to 120 degree. So then you get what? R is equal to also you get p, that is also similar to q. That means when the two equal vectors with 120 degrees, its resultant vector is similar to the either any vector magnitude. That means here what is the answer here? 120 degrees. This is a direct question. In this way different questions are asked on the parallelogram law of vectors. Here you have to focus like these questions. In the next class we will discuss scalar product and vector product. Okay, thank you, have a nice day, bye.